On a clear, moonless night above our heads, we can observe thousands of glistening stars. But that's just what we can see with the unaided eye. Observe the galaxy with powerful telescopes, and billions more are revealed. In fact, the Milky Way galaxy alone is estimated to have between 100 to 400 billion stars. And look even further to our neighboring galaxies and beyond, and there are an unaccountable amount more. The closest star to us, the Sun, appears enormous, the largest body in the solar system as it rises and sets every day. And although it dwarfs most things that come close to it, in reality, the Sun is just average-sized. The universe boasts far larger stars that aren't just a little bit bigger, they are stunningly bigger. So how big is the largest star we have observed so far? How big can stars theoretically grow? And whatever happened to WOH? You're watching V101 Space. My name's Rob, and if you enjoy my videos, then remember to subscribe and tap the notification bell to never miss an upload. When it comes to the largest stars in the known universe, it depends on whether we are talking about mass or total volume. Mass can be thought of as how much matter a star contains, whereas volume is how much space it takes up. The most massive stars tend to be quite unremarkable when it comes to sheer size, and the most voluminous stars often contain a lot less matter considering their physical size. As stars get older, they tend to lose their mass. This is something that is happening to the Sun as it grows in age. Until eventually, in an estimated 5 billion years from now, after it has exhausted all of its nuclear fuel, it will evolve into a bloated red giant engulfing the orbits of Mercury, Venus, and possibly even Earth. And although this process will make our Sun enormous, there are stars out there that come a lot bigger. Before we look at the largest by sheer physical size, let's look at the current largest by mass, named BAT 99 to 98. This star is an estimated 226 times the mass of the Sun. That's 226 suns worth of matter all crammed into one. How this star became so massive isn't fully understood, but it may be the result of two stars that once merged together. Scientific models suggest that BAT 99 to 98 is only 7.5 million years old, making it extremely young compared to the age of the Sun at 4.6 billion years old. And it is also shedding its mass at a rapid rate since its birth. Models suggest it has lost 20 suns worth of mass already. Because of how active it is thought that it will inevitably end its life in a catastrophic way, most likely a supernova that leaves behind a black hole. But although BAT 99 to 98 is extremely massive, it is nowhere near the largest by physical size. With an estimated radius of 37.5 times that of the Sun, it doesn't even come close. If you type into Google, "What is the largest star in the universe?" you will receive pages of websites telling you it is WOH, a red supergiant that just a few years ago was considered the largest star by physical size ever observed. It was originally measured to be around 1,700 times the size of the Sun. However, it turns out that the distance of WOH from Earth had been measured incorrectly, significantly altering its estimated radius to 775 times the size of the Sun, knocking it well and truly off that top spot. This new measurement actually puts WOH closer in size to popular stars like Betelgeuse or Antares, still unbelievably enormous, but nowhere near the largest. In fact, it currently doesn't even make it into the top 80. So what about another star that was also believed to be the largest just a couple of years ago, named Stephenson 2-18? A possible red hypergiant star that was estimated to be so big, if it was placed in our solar system, it would engulf the orbit of Saturn. And if you could travel around it at the speed of light, it would take almost 9 hours to complete one loop. In comparison, making the same trip around the Sun would take only 14.5 seconds. Some estimates put Stephenson 2-18 at being 2,150 times the radius of the Sun. But according to the stellar evolutionary theory, that might be problematic because there could also be a theoretical limit to how big stars can apparently grow. According to the theory, the limit a star can grow is around 1,500 times the radius of the Sun. This could mean that Stephenson 2-18 has been overestimated, possibly due to its distance from Earth being uncertain by as much as 50%, which, like WOH, would significantly alter its estimated size. But then again, as far as I could find, there is no clear-cut equation that determines how big a star can grow, since it depends not only on mass but composition, evolutionary history, and the strength of its stellar wind. For potential giant stars such as Stephenson 2-18, the outer atmosphere can, in theory, continue to puff up and grow essentially without limit. However, at some point, the diffuse gas of its outer layers becomes merged with the interstellar medium and cannot really be regarded as the stellar surface. So when it comes to measuring the size of a gigantic star, it turns out that it's no easy task. These objects are, of course, extremely big, thousands to millions of times the volume of the Sun, are extremely far away, and are extremely luminous. And as I just mentioned, they also tend to have far-extending atmospheres and photospheres that are ever-changing and are often shrouded in enormous clouds of dust, making their true size very difficult to discover. Nonetheless, astronomers attempt this by using a range of different factors such as the distance and the environment around a star. By discovering these measurements, among other things, they can more or less get estimates that fall within a smaller or larger area of confidence. So based on our best measurements, what is the current largest star in the known universe? Well, according to the list of largest stars known, that title is currently held by a red supergiant called W26, in the constellation of Canis Major. A star located around 160,000 light-years away in a neighboring satellite galaxy called the Large Magellanic Cloud. W26 has an estimated radius of 1,540 times that of the Sun, meaning that if it took the place of the Sun in the solar system, it would engulf the orbits of Mercury, Venus, Earth, Mars, and even Jupiter. This measured radius also fits in nicely with that theoretical growth limit and is consistent with many other large red supergiants found elsewhere. W26 is likely in the latter stages of its stellar evolution. These types of stars have exhausted their nuclear fuel, leading to the expansion of their outer layers, transforming them into true cosmic giants. The enormous star is also shrouded in a torus-shaped cloud of dust about a light-year in diameter, which consists of material it has expelled. Incredibly, it is estimated that if all the material in the torus cloud were collected, it would be enough to make our entire solar system 9 times over. So have we finally cracked it? Is W26 the largest star in the known universe? Well, probably not, because there have been other studies that have also measured this behemoth and got a completely different measurement. Although one source did put it at 2,575 times the radius of the Sun, making it far bigger than even Stephenson 2-18's possibly overestimated size. If this is correct, then it would easily engulf Saturn's orbit, and if you could, once again, travel around it at the speed of light, it would take almost 10.5 hours to complete one loop. In comparison, light from the Sun travels to Pluto in only 4 hours. So although it is clear that the universe is full of some truly enormous stars at different stages in their evolution, until we can gather more accurate measurements, which one is the overall largest isn't clear. However, with ongoing advancements in observational techniques and technology, astronomers will be able to refine their measurements and understand these cosmic behemoths far better. W26 could well be the largest star ever observed in the known universe, but something tells me that top spot will change again. I really hope you enjoyed this video. If you did, then please tap the like button and subscribe. Thank you for watching, and I'll see you next time.